Yes. Yes. So there was a hag cracked all her teeth on apples. Okay, so y'all need to come up with a G-rated, nice way to remember this. Oh my gosh. All right. Quick recap from Friday before the internet went out. We started with a couple things. These all involve right triangles. And if I have a right triangle, both of these angles are what we call acute. And they're acute because both of them are less than 90 degrees, but they have to sum to 90 degrees because there's 180 degrees. Wait.
On what page?
Oh, what about that? So awesome.
Delete it. Delete their comments. Cute. I mean, it's kind of like dashing you up, but like, call it hidden. Call it hidden. Well, is it true?
All right.
They still shouldn't be
That's what I'm saying.
commenting that on something.
Like, if somebody's stupid, you can't just be going around going stupid.
All right, so these two added 90 degrees. Theta can be anywhere you want it to be, okay? If I go from wherever, then that's where I'm basing my SOHCAHTOA, and that's what we're going to get to, okay? So this is where we get into sine, cosine, tangent. Sine of theta is O stands for opposite over hypotenuse. Cosine of theta, and we'll talk about where all these fall and why, is adjacent over hypotenuse. And T is for tangent, and it is the, can you guess? There you go. Now, we also talked about Friday with right triangles. Something that you should already know is that Pythagorean theorem, where a squared plus b squared equals c squared. Yep. Mm-hmm.
Yeah, this is all they talk about. I swear to God, like, it's the freaking thing.
That show is so good.
There's no telling. I don't know. That made the whole class remember what? He's probably talking about some old hippie called another hippie. You'll have to ask him because I don't remember. Yeah, ask him. So a couple of things before we get into the sine, cosine, and tangent. We too deep. This is one thing that I assumed y'all knew from geometry, but I was told Friday y'all did not. Remember, the longest side is across from the biggest angle. That's that hinge theorem from geometry we talked about. So if you have a string that connects your two fingers, the wider you make that angle, the longer the side has to be. That's your geometry theorem. So that's going to come in handy in just a minute. So if this was, let's say this was 20 degrees, and I know that this is not drawn to scale. That's why I hated teaching geometry. Nothing I ever did was drawn to scale. What would the missing angle be here? 70, right? What is in the entire triangle, all three sides? What's the longest side here? The hypotenuse. This is the longest. What's the next longest? Not what looks like, but based on, it does. It does. This is the next longest, so we'll call this side number 2, and this will be the shortest, side number 3, because remember that angle dictates how long the side is. And in fact, in a right triangle, the longest side is always going to be across from the, which is the largest angle in a right triangle? 90 degrees, always. You can't have any other larger than 90 degrees, because, yes. That's right. That's right. So always, 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 90 is my biggest angle. If they have to add to 180 and you've already used 90, then you got to split that last 90 up between two. So this is always going to be your biggest angle, right? Okay. So this is always my longest side. Say again. Okay. Solving a triangle involves finding all sides and angles. And before we use TRIG to do this, I just want to go back and review some of the geometry ways that you did this. If you did it in geometry. If this is, let's say this is 12, this is 7, this is 31. Solve the triangle. So find everything that's missing. You can find this angle. Yeah. It's 59. How did you find that? 90 and minus 31, right? It's got to add to 180. That's what it means to be a triangle. And now I've got a missing side. If I've got two sides and I need a third, and it's a right triangle, this only works with right triangles. Pythagorean theorem. Okay? So A and B can be used interchangeably. C has to be your hypotenuse. These are your two legs. I would leave the radical in it if you were doing this. So, well, 2 decimal places. That's what I would do. I'd leave the radical in it. It's a better answer. Sorry. You looked at me funny and I was like, maybe not. Okay. So if this would be what? What's 144 minus 95? Yeah. And we square root both sides. And so Friday y'all asked about the plus or minus, but we wouldn't take the minus. Why? You're not going to have a triangle that's going to have negative square root of 95 side, right? Because we're talking about how long it is, so you won't have a negative. So this is just square root of 95, and now it's solved. Okay. Now. We also have, let's go back to the trig for a minute. Tell me what cosine, sine, cosine, and tangent is trig. I was just giving you some background that you might know. How do you find the cosine of theta? Adjacent over hypotenuse. How about the sine? Because I'm going to tie it into something else. Yeah. But if you remember SOHCAHTOA, look, SOHCAHTOA. That's what it's for. SOHCAHTOA. Yeah. Now, technically, you should have been introduced to these three functions in geometry.
Oh, we were not. No. We were, yeah. I was kind of sad.
All right, so we add 3 more to it. If you didn't already know the 3, you're adding 6 to your repertoire. But if you did know the first 3, then you're only adding 3 more. The first is secant. Secant is the flip. Secant is the flip of sine. No, secant is the flip of cosine because the S and the C go opposite. So it's going to be 1 over cosine, or just the reciprocal, it's going to be hypotenuse over adjacent. Okay. Now, this is where it gets confusing, and you have to remember because you always want to put secant with sine because they both start with S. That's the opposite. Secant goes with cosine. It's the flip of cosine. Cosecant goes with sine. It's the flip of sine. And then the last one goes with the one that you think that it would go with. It's cotangent 1 over the tangent, which is adjacent over opposite. These are what we call reciprocal trig functions. Why do you think that? My goodness, they're the reciprocals of their parents. Okay, this is very important if you haven't figured that out, so I'm going to leave it right here for a second. I probably should have started with sine since I start with SOHCAHTOA. But... Okay, thanks, Stella. Thank you, guys. I appreciate the support. Yeah. Okay.
Oh my gosh, you know, something fires the other day. I saw her at Mr. CHS.
I saw she had pictures posted that she was there. It's okay.
Okay. I thought she was.
Find all 6 trig functions of theta in exact form. What?
I don't know how to find.
Okay. First thing we need to do is find the missing side. Okay, because for all 3 trig functions, we're going to have, or for all 6, we're going to have all 3 sides. So let's find this missing side. I can do that using what? Pythagorean theorem. What do I have? I have the 2 legs. I don't have the hypotenuse. That's exactly right. So 8 squared plus 4 squared is going to give me the hypotenuse squared. So 64 plus 16. And I do want to split this up if I can. 16 and 5. So 4 root 5. You were right. Downhill from here. All right. First of all, when you're sitting on theta, I'm sitting on theta. Which side is the opposite? 4. That's the one that never, ever, ever touches theta. It's completely opposite. So look at the triangle. Which side never touches? This one, right? Okay. Now, that's if this is theta. If I move theta, then my opposite sign changes, right? Okay. All right. Listen. Theta here. If this is theta, then this is the opposite side. This is always the hypotenuse. It doesn't matter what happens. That makes this side adjacent. Think about like your neighbor lives adjacent to you, right? Okay. It touches it. But one side's also going to be the hypotenuse. So you're going to have an adjacent and a hypotenuse. Now this changes if theta changes. If this is my theta, then this is my opposite side. There you go. That's right. So it depends on where you define theta as to what your sides are. Does that make sense? Hypotenuse is the only thing that doesn't change. It'll tell you which one is theta. Okay, for now. All right. All 6 trig functions. Watch what happens. The sine of theta equals, what's opposite? sine.
Oh, wait. Opposite over hypotenuse.
There you go. So, this is the so, right? So I take the opposite side, which is 4, over the hypotenuse. Say again? We're doing all 6. I just started with sine. 4's cancel out. I can't have a radical in the bottom. No, because these have to be exact. There's my sine. Here's your sine. Here's your sine. Just kidding. Okay, cosine. Same thought process. Which is what over what?
8 over
2 over square root of 5. Whoa, Hosey. Square root of 5, square root of 5. You're loving this? It's pretty straightforward. Yes. All right. Tangent theta.
I love that.
Still not done. Which reciprocal function goes with sine? Cosecant or secant? Cosecant. Here's the abbreviation, CSC. CSC is the abbreviation for cosecant. Yep. But here's the thing. Look, I don't want to flip this one because then that puts my radical back on the bottom. I would flip the original if it was me. I would say 4 root 5 over 4, which is square root of 5.
Bro, this is the most like overhyped.
Oh, so you just took the original one. Okay, that's gonna be so wonderful.
Yeah, or go back to the triangle and instead of that, do hypotenuse over opposite. All right, how about the secant?
That's fine. I thought we should do cosine first. No. Is that SEC or
SEC. All right, I'm gonna again, since I had to rationalize the bottom, I'm gonna flip it the original version. 4 root 5 over 8, so square root of 5 over 2. You should have.
It's like as far as we're going.
I have one more thing to show you. And you should have learned this in geometry, but judging by some of your faces and the reaction that I'm getting, I need to go over it quickly. I don't understand why you didn't see this in geometry, because this is so important. It comes up in here all the time. It comes up in calculus all the time. It comes up everywhere all the time. Special right triangles, SAT and ACT, all the time on special right triangles.
That's probably what I did.
So, okay, it has to be a right triangle. Here, there are 2 types. There's a 45, 45, 90. And there's a 30, 60, 90. These are very special, and I'm fixing to show you why. Now, I want you to think about that hinge theorem that we talked about just a minute ago, where we talked about the side corresponds to the angle length, right? So if the angles are the same, The sides are the same. So this is actually an isosceles right triangle, which means that the sides are the same here, okay? And the pattern for an isosceles right triangle or a 45, 45, 90 triangle says, whatever this side length is, this must be the same. And to find the hypotenuse, instead of working through that whole Pythagorean theorem, it is just you take the side and you multiply by the square root of 2. Which seems easy enough when you're going forward. It's when you're going backwards that it starts becoming an issue. In other words, if I'm given this and have to find the leg, instead of multiplying by the square root of 2, I got to divide by the square root of 2. That's exactly right. No. It's always exact on these. These are always exact. If this is a 30, 60, 90 triangle, you know the last two remaining angles are 30 and 60 because the 90 angle is marked. Which one up top should that be? Should that be the 30 or the 60 up top? Why? Look at it the way it's drawn. The bottom's longer, which means the angle across from it must be bigger. Remember that hinge theorem, right? Thanks, Joyce. Dang. Y'all should have had me for geometry. I'd had rubber bands around your fingers and we'd have been doing like that. Geometry was my least favorite, but I did a good job teaching it. Thank
You were so clever. Didn't care about perseverance.
I did when I taught honors geometry, we had postulates and theorems tests or quizzes, major quizzes every Friday. That was a given, and they were cumulative, so they just kept adding on there, and I'd randomly take off one or two and add them. And then proofs. Well, that's what. Once we got halfway through, that's all we did was proofs, because that's all geometry really is. Once you learn the theorems, it's proofs. Because you haven't been taught them. That's why. All right, the sides of the triangle. So here's the key to a 30, 60, 90. Always start or make your way back to the short leg. And I'm going to call it SL from now on. Okay? Short leg, bless you, is across from the smallest angle. So this would be my short leg, this would be my long leg, and of course this is my hypotenuse, okay? From the short leg, I'll call that X. To the long leg, I take that X and I multiply it by the square root of 3. Which makes sense. It's easy to remember 30, 60, 90 square root of 3, right? 45, 45, 90 square root of 2. Here's the one you'll get mixed up. The hypotenuse is twice the short leg. Everybody wants to do that on the 45, 45, 90, but that's not it. It just is. If you Pythagorean theoremed it out, it would work.
How did they come up with that?
No, because you'll only be given one side, not two. You won't be able to. Then you'll be a mathematical genius smarter than any ON that has existed yet, because no one has found out a way to do that without. All right, so for example, let me show you an example of this because it's the hardest. Let's say solve the triangle. You do? 30, 60, 90. All right, listen, because this is going to get confusing. All right, 30 is my missing angle. I know that. I only have one side. I can't use Pythagorean theorem. But I need to make my way back to the short leg. Divide it by square root of 3. What if I'd started with the hypotenuse? Divide by 2, right? I'm always making my way back to the short leg. So here, This would be 15 over square root of 3. I can't leave it like that. Which is how about the hypotenuse? You multiply that by 2 because everything works from the short leg. That's the key. So this is 10 root 3. You no.
Can we do one together too, actually? While we're on the
Solve that triangle while I hand your homework out.
Is that one?